Welcome to Life Science Law channel. We were discussed about topic regarding DMLT pathology, all kind of things. So in that lecture we have already covered four topics, but now we will focus on colorimeter. Everyone knows what is colorimeter is, and this is the picture of colorimeter. So in introduction, colorimeter is mostly used in clinical biochemistry. The instruments measure the absorbance or optical density of the colored solutions in the visible range colorimeter. Filter that provide a close range of the selected wavelength. We have to set some wavelength here. In colorimetric determination, a specific reagent is used which react with a specific components to form a colored complex. The concentration of colored complex is directly proportional to the concentration of components. Colored complex is measured on a photometer or spectrophotometer. The photometric readings are compared with known primary standard or with a quality control serum sample. So in principle, the working of photometer and spectrophotometer is based on Beer's and Lambert laws. This is the picture of Beer's and Lambert's law. The simplest expression of these laws are as follow. So in Beer's law, it states that optical density of the solution is directly proportional to the concentration of the solution. So here you can see initial and transmitted light. Then Lambert's law, it states that optical density of the colored solution is directly proportional to the path of the light, that is diameter of cuvette. So you can see in this picture also light will travel through cuvette and this is the path of the light. Then according to Beer's and Lambert's law, the absorbance of solution containing light absorbing material and depend on the following factors like the nature of the substance, the wavelength of the light, path of the light, and the amount of colored material in the light path. Basic components of colorimeters are like, so you can see in this picture, light bulb means a light source, a lens means condenser, filter, cuvettes, and a galvanometer. Now we will see basic procedure of colorimeter. First of all, we have to pipetting of reagent in 3 test tubes, and we have to label that test, standard, and blank. Addition of specimen and standard in the respective tubes and distilled waters in blank. Keeping the tubes for incubation at specific temperature. Reading the intensities of the test and standard against blank at the specific wavelength. Calculating unknown concentration by Beer's law. In analytical procedure, comparison of blank, standard, and test means by developed color, okay, is measured. So according to color we will analyze this procedure. Then the concentration of unknown is calculated by a formula. Concentration of unknown is equal to OD of test divided by OD of standard, then concentration of standard. Care and maintenance. So always put a plastic cover on photometer when it is not in use. Before putting photometer on, put a filter and cuvette filled with distilled water in the respective position. Most of the biochemistry experiments are based on photometry, hence use in the photometer very carefully. Check the sensitivity of galvanometer occasionally by using a standard dichromate solution. So this was all about colorimeter. In next lecture we will discuss about Neubauer chamber. So this was all about today's class. Thank you.